And so this is a practice paper for the higher level non-calculator GCSE with Edexcel. We have to do 6.37 times 2.4. So we move the decimal point so that the numbers become whole numbers. So the 6.37 becomes 637 because we have moved the decimal point 2 places to the right. And the 2.4 becomes 24 because we've moved that 1 place to the right. We do this as a long multiplication sum. And we have 4 times 7 is 28. 4 times 3 is 12 plus 2 is 14. Carry the 1. 4 times 6 is 24 plus 1 is 25. Put down a 0. 2 times 7 is 14. 2 times 3 is 6 plus 1 is 7. And 2 times 6 is 12. And so we add these together. And we obtain 8. 5 plus 7 is 12. That's 5. That's 1. So we have 15288. We move the decimal point 3 places to the right, which has the effect of multiplying the sum by 1,000. So I must undo that and come back 3 places. 1, 2, 3. So the decimal point will go between the 5 and the 2. And so the answer is 15.288. Now in this question we have to do 48.96 divided by 1.2, and it's best to express this as a fraction. We need to make the numbers whole numbers, but this time the number of places we shift the decimal point to the right has to be the same in both numbers. Because when you have a fraction, and all division sums are fractions, 3 over 4, you keep it the same by multiplying the top and the bottom by the same number. So we look at the bottom number, that needs to go 1 place to the right. The top number, it needs to go 2 places to the right. So we have to do both of them 2 places to the right. 1, 2, 1, 2. And this has the effect of multiplying top and bottom by 100. And so we are keeping the sum the same. And so we have 48.96 over 120. And it should be fairly easy to see that 12 goes into both of those. So that if I divide the bottom by 12, I get 10. And then over here, I'm doing 12s into 48.96. 12s into 48 is 4. 12s into 9 is 0. 12s into 9 is 0, remainder 9. And 12s into 96 is 8. So we have 408 divided by 10. And the answer is 40.8. In this question, we are concerned with a Venn diagram where the universal set of the odd integers less than 20. In A, we have 3, 7, 13, and 19. And so using the smaller set, we should check for which are in both. So we see in A we've got 3, and in B we've got 3. In A we've got 7, that's not in B. 13, that is in B. 19, that is not in B. And so I now have all of the numbers that belong in the intersection. Because A is the smaller group, it's easier to work with. So you've got 4 members there. 3 and 13 we've accounted for, and 7 and 19 are the only ones that go in there. In B, we got rid of the 7 and we got rid of the 13. So the only ones that go in there in B and not in A are 5, 11, and 17. And we now have to think about the universal set. which are all the odd numbers less than 20. So I count up 1, whoops, put that bit up, 1, 3, 7, 9. Can't see a 9 there, so that must go. 11, 13, 15. Can't see a 15 there. 17, 19, and so we are now complete. And in this question we have to do 3 2/5 minus 2 1/2. So it is 3 plus 2/5 minus 2 minus 1/2, which is 3 minus 2 plus 3/5 minus 1/2. Let's make that a bit clearer, shall we? Minus 1/2, which is the same as 1 plus 3/5 minus 1/2, which is the same as 1 minus 1/2 plus 3/5, which is 1/2 plus 3/5. And then make the bottom numbers the same. 5 times 1 is 5, 2 times 3 . This is a practice paper for the non-calculator paper in the higher level of Edexcel GCSE maths. In the first question, we have to work out 6.37 times 2.4. So, 6.37 times 2.4. We have to shift the decimal point so the two numbers are both whole. With 6.37, I go 2 places to the right. With the other one, it's 1. And so I'm now doing 637 times 24, which I now do as a long multiplication sum. 4 times 7 is 28. 4 times 3 plus 2 is 14. 4 times 6 is 24 plus 1 is 25. So let's just remove a couple of bits there. And now I have to put the 0 down. And I have 2 times 7 is 14. 2 times 3 is 6 plus 1 is 7. And 2 times 6 is 12. So that's 8, 8, 12, 5, 1. So the digits I have obtained are 15288, which when I put the decimal point 3 places to the right, I multiplied the sum by 1,000. So that's 1,000 times too big. The decimal point is here at the moment, we can't see it. So I have to bring it back 3 places to undo the multiplication by 1,000. And so 15.288 is the answer. Now in this question, I'm once again concerned with decimals. I'm doing 48.96 divided by 1.2, and in this case I once again have to move the decimal point to make them both whole. If I do it one place to the right with this number here, that'll make it into 12, which would be okay. But if I do it one place only with the other one, I've still got a decimal point there. I must do it the same number of places in both cases, because when you have a fraction, you can only keep it the same by multiplying top and bottom by the same number, which is what we're doing here. And so we're going 2 places to the right there and 2 places to the right there. So this is 4896 over 120. And it should be easy to see that 12 must go into both of those numbers. If I divide that bottom by 12, I get 10. If I do 12s into 4896, I get 12s into 48 is 4. 12s into 9 is 0, remainder 9. Tells into 96 is 8. That is 408 upon 10. And so the answer equals 40.8. In this question, I am concerned with integers in a Venn diagram. The universal set, odd integers less than 20. We've got A, which is 3, 7, 13, 19 there, and B, the other one. First order of business is to fill in the intersection. So if you look at A, 3 is in both A and B, so that goes in there. 7 is not in B. 13, yes, that's another one. 19 and 17, no. So we look at A. We've dealt with 3 and 13, but the 7 and the 19 need to go in there because they're in A and not in the intersection. In the case of B, we've already dealt with the 3 and the 13, so what is left over goes in there. And then to take care of the universal set, I simply count up from 1 and see what's missing. So 1, we haven't had that one yet. 3, yes. 5, yes. 7, yes. 9, no, so we've got 9 there. 11, 13, 15. No, I don't see that there, and that has now completed the Venn diagram. Now in this question here, we have to subtract some mixed fractions. So that is 3 plus 2/5 minus 2 minus a half, which is 3 minus 2 plus 2/5 minus a half, which is 1 plus 2/5 minus a half, which is 1 minus a half plus 2/5, which is 1/2 plus 2/5. So making the bottom numbers the same, we have 10, 10, 5, 4, and the answer equals 9/10. In this case, we are concerned with percentages. And the value of Terry's house was £240,000, and it will decrease by 30%. The value of Robert's house was 180,000, and it will increase by 20%. So that means that Terry's house will be 70% of what it is now, and Robert's will be 120%. So to find out what's going on with Terry, we do 70% of 240,000. And there we cast out the hundreds. And we've got 70 times 2400, which is 7 times 24 times 1,000. So we need to do 24 times 7. 7 4s are 28. 7 2s are 14, plus 2 is 16. And we multiply by 1,000, put the X naught on, and that's where Terry's got. And now we look at Robert, and he's got 120% of £180,000. Cast out the hundreds, and that is 120 times 1,800, which is 12 times 18 times 1,000. So that 18 times 12, 2 18s are 36. Put down the 0, and we obtain 216. So this is 216 times 1,000, and that is Robert. But the question asks whose house had the greater value, so you must write answer equals Robert. You're asked name. And in question 5, we are concerned with ratios. Rob, Mary and Ian collect stickers in the ratio 3:5:14. Rob, Mary, Ian, 3:5:14. Ian has 27 more stickers than Mary, and he has more stickers than Rob. How many more? So Ian divided by Mary, if you look at the numbers in the ratio, is 14/5. Mary is there and Ian is m plus 27. So if I take this bit here and I multiply both sides by m, I get 14m over 5 equals m plus 27. And if I now multiply both sides by 5, I get 14m equals 5m plus 135. I subtract 5m from both sides and I find that 9m is 135. So m must be 135 divided by 9. 9s into 13 is 1 carry 4. 9s into 14, sorry, 9s into 45 is 5. And so we can now see that Mary has 15 stickers. It also shows we've got a scale factor of 3 because 5 times 3 is 15. So 14 times 3, which is 7 times 2 times 3, which is 7 times 6, is 42. So Ian has 42. 3 times 3 is 9. And so if we do Ian minus Rob, and we find that that is the answer. Now, in this case here, we have a right triangular prism whose base is 6 centimeters, whose height is unknown, and whose length is 35. The volume is 735 centimeters cubed. We have to work out the height of the prism. Now, the volume of the prism is the triangular cross-section times the length, and that's going to equal 735. The triangular prism is h times 6 over 2. We multiply by 35 and we get 735. So that is 3h times 35 is 735. So I'll put this over here. 3 times 35 times h is 735. Now, without a calculator, perhaps the best thing to do would be to, if you like, cancel down. And we can see that 7 goes into 35 and 735. We've got 700 plus 7 times 5. 7 into 7 is 1. 7 into 35 is 5. And then 3 times 5 times h. I've divided the 35 by 7. And so here I can divide by 5. 5s into 105. 5s into 10 is 2. 5s into 5 is 1. And so 3h is 21, and h equals 21 upon 3. So that h equals 7 centimeters. And so in this case, we're concerned with volumes, and I beg your pardon, we're concerned with surface area. The surface area of the cube is equal to the surface area of the sphere. So the surface area of the cube, which is 6 squares, each of edge y. So 6y squared is the surface area of the cube. The surface area of the sphere is 4 pi r squared, which is 4 pi times 6 squared. And I have to work out y in terms of m and pi. So I've got 6y squared is 24. I beg your pardon. Is 4 times pi times 6 squared. I can divide both sides by 6 so that y squared becomes 24 pi. So y is the square root of that, and m equals 24. And in the case of this question, we have to solve a quadratic. To solve a quadratic, you have to make it equal to 0. So x squared minus 7x minus 18 equals 0. We want two numbers which multiplied together make minus 18 and added make minus 7. So the fact that when multiplied together they make minus 18 means there are different signs, 1 plus, 1 minus. But with leaving that on one side and compile a table of factors of 18, starting with the number 1 first. 118, then count up. 118, 2, 9, 3, 6, 4, no. 5, no. 6, we've had it, and so we are complete. And now we are looking for two of those we can add together with different signs to get minus 7, and they are plus 2 and minus 9. And so we now know that x plus 2 times x minus 9 is equal to 0. Therefore, either x plus 2 equals 0, in which case x equals minus 2, or x minus 9 equals 0, in which case x equals 9. So x equals minus 2, 9 answers. Right, question 9, part A. Write down the value of 8 to the power of 0. Any number to the power of 0 equals 1, so the answer equals 1. Find the value of 5 times 5 to the 6 times 5 to the minus 6. That is 5 times 5 to the 6 times 5 to the minus 6. That, of course, is the same as the 5 to the power of 1. When you multiply the numbers, you add the indices. So the answer is 5. Find the value of 3 to the power of minus 4. A to the power of minus m is always 1 over a to the m. This, therefore, is 1 over 3 to the power of 4. 3 to the power of 4 is the same as 9 times 9, and so that is 1 over 81. And now in the last one, we have 64 to the power of 1/3, which means the cube root of 64. You would be well advised to learn all the cube numbers, from 1 cubed is 1 to 10 cubed is 1,000. We know this from general knowledge. It is 4. If you don't know it, you can think about the fact that 8 times 8 is 64. This is 4 times 2 times 2 times 4. And that is 4 times 4 times 4. In question 10, the shape is made from 6 identical squares. The total area is 2,406, and we have to find an estimate for the length of one of the edges of one of the squares. So each individual square will be 2,406 divided by 6. that will be the area of each individual square. 6 into 24 is 4, 6 into 0 is 0, 6 into 6 is 1. So each one of those squares is 401 centimeters squared. And in order to find out the length of one of the edges, we have to consider the square root of 401. Now, the square root of 400 is equal to 20. So the answer to the nearest whole number is 20 centimeters. And that is the nearest whole number. In part B, we're asked, is this an overestimate or an underestimate? The square root of 401 is greater than the square root of 400, which is itself 20. And so we have an underestimate because 20 is smaller than the square root of 400. And now we have two rectangles. The area of A is equal to the area of B. Find an expression for Y in terms of W. So the area of rectangle A is 8 times W plus 2Y. And that has to be the same as 9 times W, 5Y plus 6. And we have to make Y the subject of that. So we multiply out the brackets. And then we want to get everything which is Y on one side and everything which is not Y on the other side. So if I take 8W off each side and I take 45WY off each side, I get 16Y minus 45WY equals 46W. And now I need the Y written in only one position because I want Y equals. At the moment it's in two positions. And so I factorize. And I get Y, lots of 16 minus 45W equals 46W. And so if I divide both sides by the stuff in the brackets, I get Y equals 46W over 16 minus 45W. And now this is for a cumulative frequency diagram. So in this, we've got the heights of these plants, so 5 of them are between 0 and 5, 10 of them are between 0 and 10. So those 10 here, they include the 5 we've just mentioned, plus 5 more that are between 5 exclusive and 10 inclusive. And what I've done, I've put dots on the diagram in the place indicated by these numbers. You are supposed to draw a smooth curve through this. It doesn't come easily to me particularly. You should have your hand inside the curve. So here we've got a curve that's going round here, and you should have your hand inside it when you go round. I'm pretty hope there's this sort of thing anyway. Here, to get your hand inside the curve on the other bit, I'd put your hand, I'd turn the paper around and put your hand where the arrow is. I'm just going to drawing these up with straight lines, but you shouldn't really do that. But I'm not really any good at this drawing line. But just try and make it a smooth curve if you can, and do not spend too much time on it. They only want to know, really, if you know where those dots go. Most cumulative frequency curves have a sort of flattened S shape like that, but they don't have to. And now we have to change that recurring decimal into a fraction. So we let x equal 0.363636, and it goes on forever. So therefore 100x equals, moving the decimal point 2 places to the right, 36.363636. But if you look at that, that is 36 plus x, because this is the same as x, it goes on forever. And so if I take x off both sides here, I obtain 99x equals 36. I want to know what x is, because this is the thing I was asked about. Divide both sides by 99. X equals 36 over 99. I don't absolutely have to cancel down because they didn't tell me to, but that goes down to 4/11ths, because 19 goes into top and bottom. Now, in this case, we have to find the area of this L shape in terms of x. If we think about it, it's a rectangle with this bit having been taken off. So if I could get the area of the whole rectangle, which is x plus 12 times 3x plus 5, and then I subtract this rectangle. The height is 5, so what I've got to do now is to find how long this bit is. And that bit there is the same as 3x plus 5, the whole of this, minus x plus 2, minus x minus 2. 3x minus x is 2x, 5 minus 2 is 3, 2x plus 3, and so the area of this is 5 lots of 2x plus 3, which is 10x plus 15. I'm going to subtract that in a minute. I now multiply out these brackets. First, 3x squared, x times 5, twelve times 3x, 12 times 5. And so I have 3x squared plus 41x plus 60, take off 10x, take off 15. In fact, that'll look a bit better. I put it underneath the bit I'm doing it to. Okay, so I take off 10x, and then I take off 15. And so A, the area, is 3x squared plus 31x plus 45. And in this case, I'm concerned with fraction arithmetic in algebra. So I make the bottom numbers the same by multiplying them together. So I've got 6x there, and I've got 6x there. I multiply the 5x plus 2 by 2, so I get 10x plus 4, because I'm doing that. And 3x times 1. Let's write that a bit neater. 10x plus 4 over 6x plus 3x over 6x. So 10x plus 3x is 13x, so I get 13x plus 4, 6x off the bottom, and I am done. And in this case, we have 4 red counters and 3 yellows in a bag. James will take out 3 counters, work out the probability, he gets only 1 yellow counter. We have to think of the patterns on which this can happen. Yellow, red, 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 yellow, red, 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 yellow. And because it's the first one, or the second one, or the last one, we're going to discover each of those probabilities and multiply them together. So the probability that the first one is yellow is going to be 3 out of the total number of counters which there are, which is 7, because there are 3 yellows and 4 reds. We've now taken 1 out, so there are only 6 there, but there are 4, and 4 of them are red. We want this for the second one. And then there are only 5 left, and this time only 3 red counters. And so that is 3 times 4 is, that's 36 over 210. So in this case, we have a red one first, which is 4 out of 7. Then there are 6 left, and 3 of those are yellow. And there are 5 left, and we're going to get another red one. Which is 36 out of 210. And so the first one in this case is going to be red, so that is 4 out of 7. The next one is going to be red, so it is 3 out of 6. And the last one is going to be yellow, so that is 3 out of 5. And once again, we have 36 over 210. So we have 36 over 210 plus 36 over 210 plus 36 over 210, which is 108 over 210, and we can leave that as the answer because they don't ask us to cancel down. In this question, I have to find the region which all those inequalities satisfy. X is less than 2 is the easiest to deal with because it only requires the line x equals 2. So I'll put that in. And I've dealt with that one. The next one, I've got y is less than 8 minus 4x. So I consider make up the corresponding equation. Y equals 8 minus 4x. And do a little table of values. If I make x equal to 0, y will be 8, but that's too big. So I'll make x equal to 2, and y will then be 0. So the point 2, 0 is on this line, which is there. And if I make x equal to 1, 8 minus 4 is 4, so the point 1, 4 is on the line, which is there. And so I should now be able to join those points up and make my line. Now I should have said this a moment ago, it's fairly obvious if x is less than 2, we must be on that side of the line. Okay? Now, in order to find out what side we are of the new line, we should apply the origin test. The inequality we are given is y is less than 8 minus 4x If the origin is not on the line, you should use it because it's the easiest arithmetic. So we say 0, question mark, because y is 0 at the origin, less than 8 minus 0. 0 is indeed, that is true. And so we're on this side of this line. And the last one I have to deal with is 2x, sorry, I beg your pardon, 2y plus 6 is less than x. So we deal with the corresponding equation, 2y plus 6 equals x. So I can put in a value for y equals 0, 0 plus 6 equals x, and so the point 6, 0 is on this line, which is there. And then I can choose another value for y. So let us say y equals 2. 2 times 2 plus 6 equals x. That's a bit too much. We'll have to do y equals 1. No, we'll do y equals minus 1. 2 times minus 1 plus 6 equals x. So that minus 2 plus 6 equals x, which is 4. And so the point 4 minus 1 is on that line. And that point is there. And so I've now drawn my line in. And I now apply the origin test. So we have 2y plus 6 is less than x. Put in the origin. 0 plus 6 is less than 0. 6 is less than 0, that is false. So it means that the origin is not on the wanted side of this line, which means that our wanted side is away from the origin, down there. And my other two arrows went like that. And so if we need to shade the wanted region, it is down here. I should have said, by the way, that these are strict inequalities, which means the regions are not included. The lines not included in the region, so strictly speaking, the boundary line should be dotted. But you can do that with your eraser after you've got your main work done. Okay? Now here we have a trapezium which has an area of 64 root 2. And that, of course, is going to be a plus b times h over 2. And we eventually have to find the length of AB, which I'm calling A here. And so we need to know the height. Now this is a bit sneaky of them, because the height of this is 8 sin 45, but you are supposed to know that the sine of 45 is 1 over root 2, because that occurs in an isosceles right-angled triangle. So this triangle, 1 unit, 1 unit, 45 there, 45 there. By Pythagoras, 1 squared plus 1 squared is the hypotenuse squared. The hypotenuse squared is 2, so the square root of 2 is the hypotenuse. So there you are. Now it says the length of AB, the length of CD, in proportion to each other, are 3 to 5. So what I can do here is to say 64 root 2 is equal to a half, that I'm getting rid of that there, okay, times h, which is 8 over root 2, times a plus b. Well, this is 3 to 5, so if I say that's 3t and that's 5t, I can put in 3t plus 5t. So I have got 8 over 2 is 4, 4 over root 2, so I've cancelled those off, right? Times 8t equals 64 root 2. I can multiply both sides by root 2. Root 2 times root 2 is 2. And so what I've got here, I've got 32t is 64 times 2. I can divide both sides by 32, and I get t equals 2 times 2, which is 4. So I add 3t to 5t. This is the one I wanted, AB. So AB is 3 times 4, which is 12 centimeters. Now with this question we have to show that 4 plus root 12 over 6 plus root 3 can be written in the form a plus root 3 over b. And so I take this and I multiply top and bottom by the conjugate. Now on the bottom I can rely on the difference of two squares. 6 squared minus root 3 squared is 36 minus 3, that would be 33. And I multiply out the top. 4 times 6 is 24. 4 times minus root 3 is minus 4 root 3. Root 12 times 6. And then extend the line a bit. Root 12 times root 3 minus root 36. So what I have on the top there if I look, I've got 24 minus 6, so there is 18. And I have got minus 4 root 3 plus 6 root 12. Now 6 root 12 is 6 root 4 root 3, which is 6 times 2 root 3, which is 12 root 3. So I've got minus 4 minus 12 root 3 minus 16 root 3 over 33. Which doesn't quite meet the condition put in the question, but I think there was meant to be a number in there like T or something, which didn't come out in print. So the T here will be minus 16. Now in this question, we are concerned with discovering where the line y minus x equals 1 meets the circle x squared plus y squared equals 79.2, which is drawn on the diagram. This equation is the same as y equals x plus 1. So if I zoom in a bit, y equals x plus 1. The point 0, 1 will be on this line. The point 2, 3 will be on this line. The point minus 2, minus 1 will be on this line. And I can draw this through here and through there. And all I have to do now is to read off the values on the axes of the 2 points. Now, this is not quite such a good estimate as you'll get when you get the properly printed question paper in the exam. I had to make up my own graph for this, and those are the approximate answers. But just go with whatever your graph tells you in the exam and you'll be okay. They want to know if you can use the graph. Now, in order to find g of f of 2, we first do f of 2 and then we do g on it. So f of 2 is 3 times 2 squared plus 1, which is 13. And then we do g of 13, which is 5 over 13 squared. And so the answer equals 5 over 169. It says the function h is such that h is f of g of the inverse of f of g. The function, so what we have got to do is to take the function g and do f to it. Just a minute, have that cleared out. That should say squared. And then do g to it. Sorry, then do f to it. And so that becomes 2 lots of 25 over x to the power of 4 plus 1. And so this becomes f of g of x is 50 over x to the power of 4 plus 1, and we need to invert it. So we let y equal 50 over x to the power of 4 plus 1 and make x the subject. Y minus 1 is 50 over x to the power of 4. We need it x to the power of 4 on top. Everything can be thought of as being over 1, and so we take the reciprocal of both sides, or turn both sides upside down. 1 over y minus 1 equals x to the power of 4 upon 50. Multiply both sides by 50. And then, of course, x will be the fourth root of that stuff. Sorry, that's supposed to be by -1, isn't it? And so h equals 50. Go back into x now. And state it in terms of x, and now we are. And in our last one, we have to find the turning point on this curve. Now, if you look, it's a grimacing parabola. And we'll want the maximum point, which we can do by completing the square. So we have -4 times x squared minus 3x minus 5. Because originally we had 20 plus 12x minus 4x. You don't want anything more than 1x squared there. That is the same as 4, lots of 5 plus 3x minus x squared. But it's always better to get the minus sign on the outside of the brackets than to work inside the brackets conveniently. So with completing the square, we halve the number 3, x minus 3 upon 2. Squared. So if I square that, I will get x squared minus 3x upon 2 minus 3x upon 2 plus 9/4. So I take off 9/4 because I only want that bit there, which is that bit there. And I have to take off 5 anyway, which is 20/4. So I have -4 lots of x minus 3 upon 2 squared minus 29 upon 4. I now multiply the whole lot by 4, and I've got -4 x minus 3 upon 2 squared minus 29. And that will have its greatest value where this bit here is equal to 0. So x minus 3 upon 2 will be equal to 0. And so my first coordinate is going to be 3 upon 2. And the other one will be this one here, because this expression is the same as y. Y equals all that lot there. And so that'll be minus 29. And those should be the turning points. Oh dear, no, it isn't. -4 times minus is a plus. That becomes a plus. Beg your pardon. And so the coordinates are 3 halves and 29.